Hi everyone. Today's very good sunshine in Stockholm. Today we are going to discuss about RAID, redundant array of independent disk, how multiple drives work together for performance and redundancy. Today's agenda: what is RAID, why RAID is needed, how RAID works, RAID levels overview, RAID 0 stripping, RAID 1 mirroring, RAID 5 distributed parity, RAID 6 double parity, RAID 10 mirroring plus stripping, RAID comparison, advantages and disadvantages, key takeaways. Let's see what is RAID. RAID is redundant array of independent disks. Combines multiple physical drives into a one logical volume. Data is distributed across drives in different configurations or else different RAID levels. Originally coined as redundant array of independent disks, standardized by Storage Network Industry Association SNIA, used in servers, NAS applications, workstations and data centers. Let's see why RAID is needed. Single drives are a single point of failure. One failure or it will be a total lost data. Performance bottleneck. One drive has limited read-write throughput. Business continuity requires fault tolerance. Large storage volumes exceeds single drive capacity. Mission critical systems need high availability, more than 99.99. Cost-effective alternative to enterprise single drive solutions, SLEDs. Let's see how it works. A1, A2, A3 and A4 original data blocks. So data blocks from host systems are sent to the RAID controller, which distribute them across multiple physical drives according to configured RAID level. The operating system sees all the drives as a single logical volume. The controller handles all the distribution and redundancy transparently. RAID levels overview. So few RAID levels: RAID 0, RAID 1, RAID 5, RAID 6 and RAID 10. So when we talk about techniques, RAID 0 uses stripping technique. We need to have at least 2 disk drives. It doesn't have fault tolerance, high speed scratch, temporary storage. RAID 1 technique is mirroring. You need to have at least 2 disk drives. It has fault tolerance for one drive failure. Use cases: OS drives, critical boot volumes. RAID 5 technique, stripping plus distributed parity. You need to have at least 3 disk drives. Fault tolerance, one drive failure. Use cases: general file, application servers. RAID 6 technique, stripping plus double parity. You need to have at least 4 disk drives. So it will help fault tolerance for 2 drives failures. And use cases: large array, archive storage. RAID 10 mirroring plus stripping. You need to have at least 4 disk drives. Fault tolerance, 1 per mirror pair. Use cases: databases and high performance applications. Let's see what is RAID 0 stripping. You can see here original data blocks A1 to A6. So data is split into equal size of blocks and written alternatively across the all drives, what we call strip block. A1 goes to drive 1, A2 goes to drive 2, A3 goes to drive 1, A4 goes to drive 2, A5 goes to drive 1, A6 goes to drive. So this doubles the read-write speed since both drives works in parallel, but it is single drive. If there is a single drive fail, you will lost all data permanently. RAID 1 mirroring. If you can see here, original data blocks A1 to A4. So data blocks written identically to both drives at the same time, what we call mirror. Drive 1 and drive 2 hold exact copies of all data. If one drive fails, other drives continue operating without any data losses. Read speed is improved as both drives can serve reads, but write are limited to 1x. Read is as both drives can serve reads, but writes are limited to 1x. Here we are going to discuss about RAID 5, stripping with distributed parity. Here the data is stripped across 3 plus drives with the parity blocks, calculated via XOR, rotated to different drives each stripping. If any one drive fails, its data is rebuilt mathematically from the remaining data plus parity. The parity position rates, so no single drive becomes a bottleneck. Here we are going to discuss about RAID 6. It's bit similar to the RAID 5, but it has double parity. Block level stripping with two distributed parity blocks as strip survives up to 2 simultaneous drive failures, require minimum 4 drives, usable capacity n-2 divided by n, preferred for large arrays where rebuild time are low, more write overhead than RAID 5 because 2 parity calculations. RAID 10, so it has combined with mirroring plus stripping. Data is first stripped across the mirror pairs A1, A3 to pair 1 and A2, A4 to pair 2. Then each pair is mirrored internally. This gives both the speed of stripping and safety of mirroring. Each mirror pair can survive one drive failure independently. Here we are going to discuss about RAID comparison table. Drives we needed: fault tolerance, read performance, write performance, usable capacity and rebuild time. When we talk about RAID 0, we need to have minimum 2 disk drives. It doesn't have any fault tolerance. Read performance excellent, write performance excellent, usable capacity 100%, rebuild time does not applicable. RAID 1, you need to have minimum 2 disk drives. You have fault tolerance, one drive failure, write performance is fair, usable capacity 50% and it is fast for the rebuild. RAID 5, you need to have minimum 3 disk drives, fault tolerance for one drive failure, read performance good, write performance fair, -1 divided by n, rebuild time slow. RAID 6, you need to have at least 4 disk drives, fault tolerance for 2 drives failure, read performance good, write performance poor because of the parity calculations, n-2 divided by n for the usable capacity, rebuild time very slow. RAID 10, you need to have at least 4. It is fault tolerance for one drive failure for a one pair. It has excellent read performance and good write performance. Usable capacity is 50%. Rebuild time is. Let's see what are the advantages and disadvantages. Advantages: improved data redundancy for fault tolerance, increased read-write performance depending on the RAID level, high storage availability and uptime, transparent to application because it appears as single volume, host swappable, capacity for failed drives, cost effective compared to enterprise single drive solutions. Disadvantage: RAID is not a backup, no protection against corruption or ransomware, write plenty on parity based levels. RAID 5 and RAID 6. Rebuild times can be long for a large drives. Additional hardware needed. RAID controllers adds cost and complexity. Capacity overhead for redundancy, mirror and parity. Controller failure can make entire array inaccessible. Let's see what are the key takeaways. RAID combines multiple drives into a one logical volume for performance and redundancy. RAID 0 speed only, RAID 1 redundancy only, RAID 5, 6 and 10 speed plus redundancy. RAID is not a substitute for backups. Always maintain separate backup copies. Choose RAID level based on workloads. Databases: RAID 10, file servers, RAID 5 or RAID 6. As drive capacities grow, RAID 5 and RAID 10 are increasingly performed over RAID 5. Thank you. Learn, build, grow beyond the